So what we're looking at today is going to be dealing more with multiplication. Now, this here is a square using the square of a binomial pattern. Now, we know that the area of a square is length times width. So if I want to know the overall area of a square, I can take length times width, yes? Now, we can use this, what they call the binomial pattern. So for this square here, I have a length of a and a length of a. And a times a is a squared, because the variable times itself is going to be a squared. Now this length here, this lower box here, because I have a length of b and a length of a. So we have a times b would be the area of this here, which is ab. Over here, again, we have b times a, which will give us an area of ab. And the last one is going to have a length of b and a length of b. So b times b is b squared. Now, if we want to find the overall area of this here, we can add those together. Well, I have a squared by itself and b squared are by itself because neither one of these are like terms because they're not the same. But I do have two ab's, yes? Yes? Yep. Now, these two are the same, yes? AB and AB? So that would give me 2AB because we can add those together, which would be a squared plus 2ab plus b squared. And it's just here, this is really, what I'm showing you is kind of a symbolistic version of what we're going to be doing. It's where we can see it as a picture. And we can replace b with negative b and get the same thing. The square of a binomial. So this here is also on the first page where we have a plus b squared is equal to a squared plus 2ab plus b squared, and we can plug the numbers in. We can do the same thing with a minus b squared. Now, this is me personally. I think trying to memorize and learn this and the patterns and how this works it helps, but it's not any more effective than just multiplying it out. Now, if it worked out that memorizing, okay, if a is 2x and b is negative 3, and I can plug it in as the following, is faster and is more effective, then yes, let's do it that way. But when we work these out and actually multiply them out, you're going to put more effort into actually trying to memorize all this and try to keep all this straight than it would be to just multiply. So these here are nice and they work out fine. Even in the Algebra 2 class, I do not go into huge detail with this here because it's not more effective than if we just multiplied the two by each other. So on the back of the first page, up at the very top, we do have this here. 3x plus 4 squared. Well, whenever I square something, I'm saying it's being multiplied by its self. So really what we're saying is I have 3x plus 4 times 3x plus 4, yes? And are 3x and 4, are they like terms? No, so we can't combine those. So what we can do is we can go on and use our distributive property, our multiplication property like we did last week. We can multiply 3. Now 3x times 3x, well 3 times 3 is what? Because 3 times 3 would give us 9. X times x will give us x squared, yes? Then what can we do? 3x times 4. Since they're both positive, it'd be plus. 3 times 4 is 12. And then we would have x to the first, because we only have one x out of either one. So it'd be x to the first. Questions on this here? Okay, now we can move on to the next one. We can do 4 times 3x. Well, 4 times 3 is going to be plus 12. Because 4 times 3 would be 12. And we do have just one x, so it'd be x to the first. And lastly, we have 4 times 4, which would be plus 16. Questions on this here? Now we do have like terms, 12x and 12x. And that's it there. Questions on this here? Okay. So we feel okay with this here? Now the binomial pattern, the pattern that they're showing us with those formulas, would have been taking this here, a squared plus 2ab plus b squared. Okay, I've got to remember that. Now, a, the term that goes first, is 3x. Now, b is our 4. 3x squared is 9x squared. 3x times 4 is 12x plus 16. Okay, we get there. Don't write that down. Yeah, you don't have to write that down. I was wanting to show you this here because, again, this is going by that pattern, that definition. And really looking at these two, is the one in red any more effective than what we just did? Well, not too much, but we also have to remember that a squared, a plus b squared is a squared plus 2ab plus b squared. We just have to memorize that. I think just multiplying through is a little bit more intuitive. It makes a little more sense. We're just multiplying through. So I'm not going to make you do this way in red. We're just going to multiply them together. Okay, this is a little bit different because how many variables do we have now? 2. It doesn't make any difference, but it seems like it should, but our steps won't change. Because we're still going to distribute out. 5x times 5x. Well, 5 times 5 is 25, yes? So we'd have 25. X times x. X squared, yes? Because since they're like terms, we square them because we have 2 of them. Yep. We'll get there here in a second. But are we good with 25x squared? Yes? We've done that quite a bit at this point. Okay. Now we're doing 5x times 2y, negative 2y, yes? Well, I can multiply the numbers because 5 times negative 2 is negative 10. Now we said like with 5x and 5x, x times x is x squared because I have 2 of them being multiplied together, yes? Is x and y, are they the same? So if I can't turn it into because they're not the same, I can't turn it into like x squared to an exponent. So what do we guess? Is x and y are being multiplied together. So we can just write xy, which is saying x times y. Questions on these first two? So then we can move on to the next step. Well, negative 2y times 5x. Negative 2 times 5 is 10. We can do yx. We will actually leave it as xy. There's a part of mathematics called number theory. And what number theory states is that whenever we list variables, we always list them in alphabetical order and then descending powers, descending exponents. So whenever we list variables, x will go before y, because alphabetically x is always before y. So it's always a is always going to be first, and so on and so forth. So we'll list it as xy. But it's still the same as yx, because multiplication works that way. And lastly, negative 2y times negative 2y. Because negative 2 times negative 2 is positive 4. Negative times a negative is a positive. 2 times 2 is 4. Then y times y is y squared. Any questions on any of this here so far? Okay, well, we do have two like terms because the negative 10xy and negative 10xy do both have the same variables, xy, so we can combine those. So the 25x squared is going to stay by itself. Well, negative 10 minus 10 would be negative xy plus 4 . Any questions on any of this here? How do we feel about these? Feel good about these here? Are they any real different than what we did last week with multiplication? No. It's just another way that we can look at these and write these. Do we want to look at another set of these? Sure, which one do we want to look at? Which one felt harder to do, the one with one variable or two? We can do either one. We can do both of them. But you want to just do both. So 2x plus 6 times 2x plus 6. All right, so 2x times 2x is what we're going to do first. So we can multiply the numbers. 2 times 2 gives us 4. X times x gives us x squared. Right, 2x times 6, so 2 times 6 is going to be plus 12, and then we have our x. So any questions on this here so far? Then we can do 6 times 2x. Well, 6 times 2 is going to be plus 12, and we have our, and then 6 times 6 will give us plus 36. Now we do have two like terms here, 12x and 12x. Well, 12 plus 12 is 24. And that's it. Questions on this here? Go on and try B. Mm-hmm. Yep. So our 3x times 3x. So I'm starting out at the very beginning. Yeah. So 3x times 3x, which we did. Because this here would give us, because 3 times 3 would be 9. X times x is x squared, yes? Now when we do this next one here, 3 times, because it's 1, or negative 1, yes? And 3 times negative 1 is negative 3. And then we put xy. Now negative y times 3x would be negative. So here we have negative 1 times 3. So we're going the other direction. Yeah. And then you're moving on to the last one. Mm-hmm. And lastly, negative y times negative y. Negative times a negative is a. And y times y is. Negative 3 minus 3 would give us. Yes. If it marks it wrong, just let me know. Because sometimes there's been some cases where it's thrown it out because you put a 1 in front, and sometimes it's taken it, so it's here and there. So in big ideas math, I would probably stay away from it, but on my test, the handwritten test, I take either one. Because there's nothing wrong with saying 1 times y squared.
Maybe I'll get some extra credit for the effort.
For the extra one?
The effort.
The extra one.
I put more thought.
Questions on any of these here? Do we feel kind of comfortable with these here? Yes?
Do you want to
Then add something else.
No? Well, we are going to add something to it. Because really what we're looking at are kind of special cases of these multiplications. Because we've looked at multiplication last week, but we were looking at these kind of special types. And the first one we really looked at, it ended up being that the middle terms were the same on all of them. They were the same, so we ended up having it twice. Here, we're not going to have a middle term. X squared minus 4. And it works out that way every single time. It works out that whenever the parentheses, the first terms are the same, the second terms are the same, but the signs are different, it works out that it's the same. This multiplication is the same as the first term squared minus the second term squared. And it, huh?
Does the second not change? So, like, for instance,
So here we have x plus 2 times x minus 2.
well, like that, even if you, like, multiply it, the x, like, the whatever the letter is, it'll always stay behind the number, right?
Mm-hmm. Yeah, we put it behind the number. So like this here. So x plus 2 times x minus 2. So we can still do the distributive property, multiplication like we've been doing. And it'll work out just fine, and that's what I would suggest doing. But it's going to work out whatever the middle terms are will become 0. And we'll look at it. Let's go on and look at this. So let's look at t plus 5 times t minus 5. So t times t is t times negative 5. Questions? You're good? You're good. Any questions on this so far? Because the 5 times negative, or t times negative 5 is t 1 times negative 5 would give us negative 5. And we have our t. Now when we do the second set, 5 times t is going to be plus. And our last one, 5 times negative 5. Positive times a negative would be a negative.
Are we just doing
With the negative and the positive,
wouldn't the 5t, wouldn't they just get erased?
that's what I just said.
Look, but you said the t would stay there.
The t squared.
Oh, I thought you said like the t would stay there.
Now, when we look at the middle two terms, we have negative 5t and 5t, yes? Negative 5 plus 5 is 0. So the middle terms will cancel out.
I capitalized my t.
Mhm.
Is that okay?
That's fine.
Okay, because I got confused because it looks like a bunch of pluses.
Yeah, that's why I kind of have that tail attached to each one, because it's very easy to switch a t and a plus sign, especially when they are right next to each other. But it's going to work out this way. And these here are called a difference of perfect squares. And these here are kind of helpful to know, because if I look at this here, well, the first terms are t and t. Well, t squared is, well, t times t is t squared. Minus 5 times 5 is
So
25.
basically, couldn't you just, like, if you were doing it easily, couldn't you just do t times t, which is t squared, and then 5 times 5, which is negative 25, which is exactly what you have?
So here, 3x times 3x is,
9x squared.
yes, minus y times y is.
Which is y squared. And that's what I got down here.
So I'm just putting that up there so we can kind of see it. Now let's go on and multiply. 3x times 3x would give us 9x squared, because our 3 times 3 would be 9. X times x would be x squared, yes?
3 minus 3xy.
Because 3x times negative y, 3 times negative 1 would be negative 3, and then we have our x times y.
And then plus 3xy.
So are we good with this here? Now y, positive y times positive 3x. Well, since they're both positive, it's going to be plus 3xy, because it just has, the y has 1, so it's not affecting the 3. And we have our xy. Because y times negative y would be negative y squared. Well, our middle two terms are the same, but different signs, so they become 0. They cancel out, leaving us with nine x squared minus y squared. Questions on this here? So if you're able to kind of see these are different.
Mendoza, please come to the office.
So if you're able to see that this is a difference of perfect squares, and it works out that I can square the first term and square the second, and we're subtracting them, hey, you can do that. But if you like going through the multiplication and doing that all the way out, do that, because it will give you the same answer. Questions on this here? Because I feel like y'all feel pretty comfortable with these here. Yes? Let's look at number 7, because we haven't actually. I want. So on this page, let's do this one here. I want numbers in both. Because all the examples that we had either had a number with one variable or a number with the other. We didn't have one with both. It doesn't change it, it's just, I wanted you all to see the variety.
Is this just one you're just
Yeah, this is one I'm just throwing in there, so where these show up, where these 3 show up at the bottom, just go on and write this in. And there are occasions that I do this in every class, where I'll throw an extra one in there to make it a little bit, that has more variety to it. Okay. So if we're multiplying this through, what can we do first? 2x times 2x, which would give us 4x squared, because 2 times 2 is 4. X times x would give us x squared. And then we can do 2x times negative 3y. Because 2 times negative 3 would be negative 6. And then x times y is just x, y. Questions on this here? And then we'll do multiply through by the 3y. Well, 3 out. Well, yes. So our 3y times 2x, well, 3 times 2 is going to be positive 6, because they're both positive. X times y would be xy. And lastly, 3y times negative 3y will be negative. Now the middle terms will cancel out, giving us 4x squared minus 9y. Yes, but we have one last thing. We have one last thing. Any questions on any of this here? We're ready to look at the last thing we're going to cover today? Use the special product pattern to find the product of 26 times 34. Now, 26 times 34, how would you go about doing that if I told you to find the product of 26 times 34? I would plug it into the calculator. 8 what? We agree with that? Yeah. I mean, that's what we can do. Now, if we didn't have a calculator and we had to do this by hand, what we could do is I could say 26. I don't know why they'd want to do it. I would just do it this way here, because what they're wanting us to say that we can do is a squared minus b squared, using this properties here to be able to get there. Because they would want us to rewrite 26 and 34 as a terms of a plus b and a minus b, but it doesn't make a whole lot of difference. We can just type these into the calculator.